So, have you heard of this phytosequestration thing?
I have heard of phytosequestration. And I think you were referring specifically to the sequestration of carbon dioxide. So plants, of course, as they grow, they're putting away a lot of carbon.
So, what happens to this carbon once the plants get a hold of it?
As long as it's locked away, especially in soil, then it's kept there. Now, our typical agricultural practices of planting annual crops and then ripping them out and then going back and planting again has done a lot to sort of disturb that sequestration because the soil doesn't get a chance to hold on to that carbon.
I have in my notes that over the last 50 years, crop productivity in agriculture has grown nearly 100%. And for corn, half of this increase was due to genetic improvements. Is there any research being done on the genes that would allow plants to sequester more carbon as biomass?
It's already been shown that actually some of the genetically engineered plants that have been developed and are in widespread use have actually had a positive impact on this whole issue because, the two most widespread traits, there's Bt, they basically contain a protein that kills insects that eat it, and that's been shown to have several positive impacts in terms of carbon sequestration and in terms of greenhouse gas emissions. So not only is productivity of the plants increased, but you don't have to spray with pesticides, and so you're not using fossil fuels to pass these insecticides over the fields multiple times during a growing season. So the yields have gone up and we're using less fossil fuels at the same time. So it's environmentally very, very sound. The other major trait that's been engineered into some major crops at this point is herbicide tolerance. And with the herbicide tolerance, used to be such that we would spray multiple times with herbicides that are very, very toxic. Now with the herbicide tolerance, we're using a much less toxic herbicide. And the real benefit here is that you can do minimum or actually no-till agriculture. Before this, farmers would always turn the soil over completely before planting a new crop. And this was to basically kill as many of the weeds as possible before you put your seed out there. And then that would be followed by these very toxic herbicides. Now you can leave your plants in place, the soil in place. You don't have to turn it over every single growing season, which is wonderful because every time you turn it over, you're releasing carbon dioxide in the atmosphere, and you're also causing a lot of the soil to be lost through erosion, and a lot of the nutrients that are already present in the soil to be lost through leaching. And so now you can apply less fertilizer, so that means fewer passes over the fields to apply the fertilizer. The fertilizer costs fossil fuel to make, so you're not using as much of that either. And we're not passing heavy farm machinery over the field every time you need to till it to turn the soil over. Less fossil fuel use. So all beneficial, all having a net positive impact on greenhouse gas emissions.